Hello everyone! In this video tutorial, we are going to cover some of the topics included in lab number 2. Lab number 2 is a continuation from lab number 1 in the sense that we are going again to load data into R so we can do data analysis and also continue making graphs, but this time we are going to make graphs for quantitative data sets. So the dataset we are going to work with in lab number 2 is a dataset from Gapminder. Gapminder is an organization that collects data around the world. You will find in their website some interesting facts and interesting data. They also have interactive tools for visualization and also learning. I recommend you to check the website if you are interested in learning something new. I already uploaded the CSV file with this dataset into our lab folder. What we need to do now is to tell R to load the dataset into our workspace. So we're going to use the data table package that help us to work with data frames in R. So we're asking R to load that package into our workspace. So we're going to use the function fread to read the CSV file for us, and whatever information in that file, our data frame, is going to be stored in the variable Gapminder df for data frame. So Gapminder df is our data frame with all the information in the file. Now, we're going to ask R to display some of this data for us so we know what's in it. We also like to have the size of this data, also again using from base R, the dim function which tells me the dimensions of the data frame, and that's going to be stored in the variable data size. So asking R to evaluate that, so let me refresh, so let me build to be sure that the information is updated. Okay, so here from the function head Gapminder df, right? So the function head to display the first few rows of the data set. So we see in the first 6 rows. We can see here that we have 7 columns, meaning correspond to 7 variables. The first column is just a enumeration of first row, second row, and so on. And then in the second column, which is called country, you can see different countries. Right now, just the top shows Afghanistan. We also have a column for the variable continent, a column for year, a column for life expectancy, a column for population, and a column for GDP per capita. Notice that when we ask R to display part of this data set, the first few rows, it name all the columns according to the CSV file. And for the first column, it actually named V1. This usually happens when the headers do not have any text. So it tells me that my first column here had blank for header, but it did have a text for the second, third, and after. Okay, also displaying the size of the data set, we can see that there are 1,704 rows and 7 variables, as we can see from the top. What we want is to take a look at this data set, and we may have questions about the data set. One of the questions, because one of the variables is life expectancy, how long people live around the world according to this data set. So one way of finding out how long people live around the world is by asking R to display a histogram of the variable life expectancy. So in order to display a graph, we're gonna again use the ggplot2 package, which is a visualization package for R. We use that for lab number 1, where we use for plotting bar graphs. But because this data set is a quantitative data set, so we actually are interested in a different type of graph. The histogram would give us that information. So we're going to load ggplot2 into our workspace. Under ggplot2, we have the function ggplot. And inside the parameters of this function, we're going to ask to use our data set, which is in the data frame gapminder df. And for the horizontal axis, we are using the variable life expectancy. We're also going to add a layer to that. And the layer is the geom called histogram. Remember, the geom we used primarily in lab 1 was geom underscore bar. Right now we use geom underscore histogram because we would like to see this data set plotted as a histogram. And we have here a parameter for that geom, the histogram geom, color as being equals to white. We're going to see that color equals white refers to the edge of the bars of the histogram, and you can modify that for different colors. All right, so let me update my R Markdown so it's running. Okay, so you can see here that that's the code we just ran. And notice that R replies back with the information that we are using 30 beans. Beans are the classes for the histogram. Okay, so you can see here that the horizontal X has the name of the variable life expectancy or life X, and R also counts how many of each age group is in the data set. Obviously, as before, we would like to be more consistent with the labeling of this graph. So it would be nice to put a title, also rename the horizontal and vertical axis. The next part of the code is exactly this. So we still have the same previous code, and you can see that we're adding a layer called theme classic as before, and base size refers to the size of the fonts for the horizontal and vertical axis, and also the size for the title. We're gonna add our own layer saying that the vertical axis should be renamed as frequency count, and the horizontal axis should be renamed as life expectancy. Also, we're going to add the title, digititle, which is histogram of life expectancy from Gapminder. Running this code, so notice now that our histogram has a title, also the labeling of the horizontal and vertical axis changed. It is a more informative display of the data. Now, I mentioned before that the color white refers to the edge of the bars. Let's change that to blue just to you to realize the difference, that indeed this changes the color around the bars. You can see now that the graph, it's a little bit more vivid and you can really distinguish the bars there, and it's in color blue. All right, so maybe you want to change the number of beans, so the next graph shows, and let me also change the color of the edges of the bars to blue color. But notice that we adding an extra parameter to the geom histogram. Separated by comma, beans equals to 50. So instead of 30 beans, 30 different classes of age groups, we're gonna use 50. So running the code, we see here, it's already updated, that we have more bars now, and they're all surrounded by blue color. And in comparison with the previous graph, which had 30 beans, you can see that the shape is similar, right? Because it's still the same data set, but now it's according to 50 beans instead of 30. We are now going to make a scatter plot to display how life expectancy around the world changes over the years. In the chunk of code for the scatter plot, the gg function is still used based on our data frame gapminder df, but we set the horizontal axis to be the years and the vertical axis to be the life expectancy. And we add the layer geom point instead of geom histogram. Now let's take a look on how the scatter plot looks. What we see in the graph is that for each year, we have a band of dots representing life expectancies for the whole group of countries in the data set. And that in general, we have that life expectancies is slowly going up over the years. In the next example, we are going to see the progression of life expectancy for a single country over the years. For that, we are going to use the filter function from the dplyr package, and as an example, we take the country to be Brazil. We didn't load yet the dplyr function, so let's do that first. And also now let's consider constructing a smaller data frame from our original data frame. Let's call this new data frame smaller df, based on our original data frame gapminder df. And we are filtering the variable country for when it is Brazil. We then apply the small data frame to the ggplot. And we continue with horizontal axis being the years and the vertical axis as being life expectancies. And also we're still doing the scatter plot. So the result of that is displayed in this graph. So we can see that we have one dot for each of the years in the data set, and that in general we can see that life expectancy for Brazil is going up in a kind of a linear fashion. Now, if we want to do a similar display but for a group of few countries, the adjustment is done in the filter function. Notice that I'm replacing the previous version of the data frame with a new one, still based on our original data frame, which is gapminder df, but this time we are filtering the country variable for values when it is an element of the list of countries, Canada, France, and Spain. And then we feed this new version of the smaller data frame to our gg function. Notice also that we needed to add a parameter to the ggplot function saying that we are grouping according to countries. So the display of the scatter plot shows 3 dots for each of the years, but notice that we cannot distinguish for which country those dots represent the life expectancy. So let's make some adjustments to the graph to improve the way it is displayed. We add our own labels to the vertical and horizontal axis. We're also going to add a title. Now the graph is going to be called Life Expectancy by Year for 3 countries. And we are also going to distinguish which dots belongs to which country by adding color for that variable. So we add in the parameter color, which is now according to countries, to the main function ggplot. And we can see here the new version of the graph now has a distinction for which points represent the life expectancy, and each color represents one of the countries listed. We also have a title. We also have vertical axis labeled as life expectancy. We also have that the horizontal axis labeled as year. Now, it may be of our interest to connect consecutive dots for each country. So the way we do that is by adding the line of code, a layer, so plus the geom line right after the geom point. And the result is this. What we saw in this lab is that we can make a scatter plot or a histogram for quantitative data sets. And we also saw that we can modify these types of graphs to better display the data that we are presenting. Now you are going to work in modifying the chunk of codes given in this lab to complete your lab exercise and also your writing assignment. Good luck!